Okay, class. Last time I paused from 1 to 4. You can check it out. Let's do question number 5. So number 5 is this. Number 5, the question was discuss the continuity of the function f and g and explain any difference. So the continuity, remember the continuity is when you have f at that point 0, 0 have to exist first, and then the limit when x and y is approaching to 0, 0 of that point fx and y is have to be equal to f 0, 0, 0. Okay? That's the definition for the continuity of the function. Now, if they ask you to discuss the limit, let's find. We know something. We know f, here this power is just f 0, 0 is equal to 0. And also here, same thing here, g 0, 0 is equal to 1. You see the difference now? That's the meaning. You see the difference? From here, from the top here, is equal to 0 for f. And here g is equal to 1 for g, okay? So this one is good. So now we can say f 0, 0 exists, okay? And then if you plug back in, if you plug directly 0 on that function of f, see the f here and g here for x and y different to 0, they are the same. Okay, that's the first thing you have to realize. If you plug the 0, the top, the bottom, if you replace x and y by 0, 0, you will have 0 and 0. And then you can do anything. So then you have to set up a path. Let's choose path x equal my. If you choose path x equal my, so limit when x and y go approaching to 0, 0 of that function mean we will have only one variable, which is y, and y have to goes to 0. So we have this one. And now we can cancel out the y square, the top and the bottom. So we end up having this one. So if you check this one, we only have y here, y this side. And y is approaching to 0 of this one equal 0. And this one are the same. 1 plus m squared divided by 1 plus m squared equal 1. Then we can tell the limit for this one equals 1. Now, since the limit equal 1, and since by definition of the continuity, the definition by continuity x, y is approaching to 0, 0, of this one, of f, for example, of 0 and 0, no, fx and y, of this one have to be equal f 0, 0. But here, the problem here, we know something. We know f 0, 0 is equal to 0 from here. Okay? F 0, 0 is equal to 0. And also G 0, 0 is equal to 1. Then since we have 1 here, then we can tell the limit x of x and y is approaching to 0, 0 of that function x squared plus 2xy squared plus y squared divided by x squared plus y squared of this one equal g 0, 0. Then we can tell right away the function is continue at point. No, the function g is continue. G is continue function at 0, 0. But you can tell it's different to G0, no, to F0. Why? Because F0 equals 0. And G0, 0 equals 1. That's why F is not continue function, okay? At point 0, 0. That's it, okay? Take a look and let me know what you get. Okay, let's do question number 6. Question number 6 is to use the color coordinate to find the limit of that function. So one thing you have to know, the color coordinate is this one. And then you know x square plus y square is r square parenthesis cos x theta square plus sine theta square. So this one is 1, and you end up having r square. That's why we have r square here, okay? And the r we cancel out, we end up having here. Now this one is approaching to 0, r is approaching to 0. So this one, it will go to 0, that's it. That's the limit. This one is easy. And then this one, the b, the number 6b, this one is just r. This one is just r, okay? And this one, you take the limit r go to 0 of this one is equal to cos 0, which is 1. That's it. Now, question number 7. Use the spheric coordinate and find the limit. The spheric coordinate is this one. X is this one, y is this one, and z is given, okay? One thing you have to know, we have to prove first before you reach here. We have to prove some things. X square plus y square plus z square. Take it here. So we have to find something here, okay? Now, let me break it down here. Check it here. I want to find this one. You have x square plus y square plus z square is equal to, where is the, okay, let me write down the formula very quick. Let me change it. You have x square plus y square plus z square is equal to, we know x is here, y is here, z is here. X is this one square sine this one square, and you have cos theta square plus this one square sine this one square, and you have sine theta square plus z is this one square, and you have cosine this one square, not this one square. So now, if you combine this one and this one, what do you got? We will get this. We will get is equal to, we can factorize this one and sine theta, and then we can get cosine plus sine and plus theta cos, and it's here. And this one is just equal to 1. So we end up having theta square, this one sine, this one square, plus this one, plus cosine, this one square. So same thing here is just 1, so we end up having this one. Now the whole thing, this one, x square plus y square plus z square is just this one. Okay? Good. So now, since now you know it, let's start now. Let me raise it so we can have more space. If you feel confused about it, just go back and stop the video and take a look. Let me just raise the red bar so we won't have easy. Okay. Now, take the limit of this one goes to infinity and replace x, y, z by its value. And here on the top, and replace it, and you end up having this one, exactly what I told you. And then here, you end up having this one. Now, if this one goes to 0, everything will go to 0, of course. That's why you have 0 here, okay? Repeat it many times so you can get the process. Number 8, problem number 8, you have found both first partial derivative. So you have this one. So if you take the integration of, from 0 to x of t squared minus 1 dt, and you take the partial derivative of f with respect of x. So you have this one. Now, take the integration first. If you take the integration, this one is here. Before you take the partial derivative with respect of x or with respect of y, take the integration first. And you end up having this one. The integration is right here. So now you can take the partial derivative of f with respect of x. Any y you see here or real numbers, take it as a constant. If you take the derivative of the constant, is 0. This one is 0. If you take the partial derivative with respect of x, this one is 0. This one is 0. So with respect of x only, you have this one and here. Okay? Same way. A partial derivative of f with respect of y, any x is constant and is equal to 0. You have only to take the derivative, the partial derivative with this one and this one. That's why you have y squared minus 1 because if you take the partial derivative with respect of y of negative y is negative 1. That's why you have negative 1 here. Okay? Good. Okay, for question number 9. Before I do number 9, I want maybe do something. 8. Okay, question number 8, C. You have this one. I think the question was, they ask you to find the partial derivative with respect of x, y, z. The partial derivative with respect of x, you have only here x. Fix this one. This one, it won't change. That's why you have it here. And take the partial derivative inside first with respect of x. Inside first. And inside one is right here. Okay? And then take the derivative of sequence. Derivative of sequence is just 10 sequence. And keep the inside one intact. It won't change. That's why you have this one. Okay? This one is good. Now, partial derivative with respect of y, you have two y's here. You have to be very careful here. Okay, the first one, you have to take the derivative and keep this one intact. Don't change it. Take the derivative for this one, you have this one. And keep it intact. It won't change. You have this one. The first one is correct. Now, the second part is you have to take the derivative, this one, and keep this one intact. This one won't change. Take the derivative, this one, sequence of x, z, divided by y. If you take the derivative, this one, you take the derivative inside first. With respect of y, is negative xz divided by y squared. That's why you have it here outside. And you take the 10 and sequence, same thing. Okay? And you keep this one intact. It won't change. And that's why you have this one here. Partial derivative with respect of z is the same way. You take the partial derivative with respect of z, and you have this one. You have z only inside, keep this one intact. Keep this one. And partial derivative of z, with respect of z, this one is 1, and you have x over y. That's why you have x over y here. And you take the derivative of the sequence is 10 in sequence. Good. Now, number 10, problem number 10, you have found the linear approximation of the function, of that function. Okay? If they ask you to find the linear approximation of that function, you have this. Now, the linear approximation for the formula is this one. This is the main formula when they ask you to find the linear approximation. And now this one is a partial derivative with respect of x, with respect of y, and with respect of z. At which point? At the point 3, 2, and 6. Just replace it. Okay? If you replace it, you have this. F at that point is 7. Partial derivative at that point is 6 over 7. Partial derivative with respect of y at that point is 4 over 7. And partial derivative with respect of z at that point is 12 over 7. and replace it here, you have this. Now, if you read the question, it says use it to approximate the number, this one. So this one, you have to plug here. If you plug back here by 3, by 2, and by 6, you end up having, here is 0, okay? Here also is 0, and here is 0. So you have only 7 left here. That's why you have 7 left here. Now, a linear approximation, so this one have to be approximatively equal to this one. Why? Because if you check this one is 7.0 something. 7.0 something, okay? That's why it's approximatively equal to, okay? Good. So now for question number 11, show that is differentiable by finding the value of this one. I advise you to check page 18. It's easy. You just have to use it and plug it back in by delta and just find the epsilon 1 and epsilon 2. That's it. You don't have to do that much work. Okay? Just go on page 818 and use that theorem. And then from that theorem and just find it. If you don't understand, we can do it in class if you want. Okay? I know you can get it. You can do it in class tomorrow for period 4 and period, I think, 6. No. For period 4, yeah, for period 4, we can do it tomorrow if you want. But I know the period 3 and period 7, they will get it. Okay. Those we can do it tomorrow. It's a lot of work. We can do it tomorrow. Okay, good. Okay.